Hello everyone and welcome back for the 5th Algebra 1 final exam review video. Today we're going to be focusing on quadratic functions. Let's get started. Alright, the first question we're going to look at is on page 49, number 12. It asks us to compare two different graphs, the graph of f of x, which is 3x minus 2 squared plus 1, and the graph of g of x, x squared. These are two different quadratic functions, which we know, of course, is when we graph a quadratic, takes on the shape of a parabola or a U shape. So if you look at the comparisons, if you look at your choices and read them through, you're seeing words like wider, you're seeing words like shifting or moving left and up or right and up, okay? And so we are being asked to compare the shape, whether it's wider or narrower, and how it moves. So one way that I would strongly encourage you to answer this question is to type these different equations, different functions, into your y1 and y2. You'll notice that all of the graphs are comparing, all the choices here are comparing the graph of f of x to the graph of g of x. So I would start by looking at the graph of g of x, and then graphing the graph of f of x, and comparing them and answering the question. Using your calculator to compare the graphs is one way to answer the question and is definitely a strongly encouraged method. I did want to talk just for a second about the vertex form of a quadratic, and I have it written down here, and I just kind of want to talk through each of the pieces and just remind you, because this does get asked quite a bit, and it's good just to even review all of function transformations. So first of all, this is in vertex form, and you'll notice that you have this x minus h squared and then your plus k. When you see a binomial squared and then plus another number on the outside, that's vertex form. Sometimes there's a number in front of the parentheses, and sometimes it's positive and sometimes it's negative. So just kind of breaking this down really quickly. This is all review. If it's a positive in front, you know that you are going to have an upward facing parabola. If it's negative, you know you're going to have a downward facing. Okay? Your a value is going to control how wide or how narrow the graph is. If your a value is a number between 0 and 1, a fraction, a decimal, then that's going to force the graph to be wider than the original. If your a value is bigger than 1, it is going to be more narrow. In this example here, as you can see, our a value is 3. And so we know that we are going to have a narrower graph. So I'm going to eliminate choice 1 and choice 4 because they use the word wider. We want narrower, okay? Next, inside the parenthesis is our horizontal shift left or right. So it depends on if it's adding or subtracting. In this case, okay, if you are adding, you're moving to the left. If you're subtracting, you're moving to the right. And so in this case, we are minus 2, and so therefore I would say we are moving to the right. All right, and so if you look at your next choice, if you look at what's left between choice 2 and choice 3, right 2 units would be choice 2. Okay, both of them say up 1 unit, and that's the last thing that is at the very end. Adding or subtracting to the end is going to move up for positive, down for negative. Okay, the next one we're going to look at is on page 65, so if you could flip with me there. We're going to look at number 36. And actually, we're going to actually change the function that they give us just slightly. We're going to rewrite it as f of x equals x squared plus 8x plus 9. Since this exam was released, they've made a decision that when we're answering a question like part B of this question, we don't need to worry about it if it has a negative in front. So we're just going to change it slightly so we can do the whole problem through. So part A just says, given the function f of x equals x squared plus 8x plus 9, state whether the vertex represents a maximum or a minimum point for the function. Explain your answer. Okay, again, you can use your calculator to help you with this. You could type this into y equals and graph it, and you will see that you have an upward facing parabola, okay? And so therefore your vertex or the turning point is going to be a minimum. Now, if that's the way you did it, your explanation would be when I graphed it, it looked like this, or it was upward facing, so the vertex was a minimum. Okay. Also, though, just like we just reviewed in the last question, if the number in front of the x squared is positive, okay, then you know that in fact it is an upward facing parabola. So we can write, for our explanation, the x squared term is positive, so the parabola faces up. Okay, part B of this question asks us to rewrite f of x in vertex form by completing the square. So I just rewrote the function for us, and I want to review with you the 3 steps for how to do this. You'll notice that phrase, completing the square. There's 2 different times when we've used completing the square in this course. The first one was to do this, to rewrite a parabola, a quadratic function, in vertex form. The second, okay, was when we learned how to solve quadratic equation using the completing the square process. They have similar steps, but they're not exactly the same. So the first step is you are going to take b over 2 and you're going to square it. So you're going to cut your b value in half and then you're going to square it. So if I look here, what is my b value for this problem? Well, my b is 8. So I'm going to do 8 divided by 2 and I'm going to square it. So 8 over 2 is 4, squared is 16. Okay. Step 2 is to add to the middle, subtract to the end. Okay, so we have to add it and subtract it away. So what does that look like? Well, I'm going to take my function, and what did I mean by the middle? Well, the middle is right after my x term. So right here, and then the end is at the very end. Okay, so I'm going to add that 16 after the 8x. Then I'm going to write down the rest of it, plus 9, and then I'm going to subtract away my 16. So this right here that we created, we completed the square to make this into a trinomial that is a perfect square. This allows us to now do step 3, which is to factor. Okay, our third step is to take that trinomial, that perfect square trinomial, and factor it into the product of 2 binomials. So if I take my x squared plus 8x plus 16, I know it's going to be x and x. I have 2 plus signs, so it's going to both be pluses in my parentheses. And then I'm looking for 2 numbers that multiply to 16 that add to 8. So the 2 numbers that multiply to 16 and add to 8 are 4 and 4. And then also I have this 9 minus 16 at the end. I can just clean that up and make it minus 7. The last thing we have to do is just to clean it up and so that it looks like it's in vertex form. And that means just this binomial, they match. So instead of writing x plus 4 times x plus 4, I can just write x plus 4 squared and then minus 7. So now that we have it written as a binomial squared plus or minus another number, that's vertex form. The next one we're going to look at is on page 66. It is number 37, which makes it the 6-point question for this exam. New Clarendon Park is undergoing renovations to its gardens. One garden that was originally a square is being adjusted so that one side is double in length while the other side is decreased by 3 meters. The new rectangular garden will have an area that is 25% more than the original. That sentence is very important. Write an equation that could be used to determine the length of a side of the original square garden. All right, so what is it we're looking for? A side of the original square garden. All right, well, let's start by drawing out the 2 different gardens that they're speaking of. So we have an original garden, okay, original. And then we're going to have a new garden. All right, so my original garden was simply a square. And when I draw a square, we know that all 4 sides are equal, so I'm going to label my 4 sides as just having x, a value of x. Okay, now it's time to draw our new garden. So what did it say? It said the sides of the garden were adjusted so that one side is double in length. All right, so I'm going to make this double in length with the original, so that would be 2x. And the other side is decreased by 3. So it's going to be shorter than it was by 3. So x minus 3. So now I have a rectangle where my length here is 2x and my width is x minus 3. Now, we've now drawn our two pictures and every variable that we've used is x. Okay, that's super important because if I am able to label all the sides of my original square and my new square all with the same variable, then I know I can write an equation using that one variable. So let's talk about the equation that I have to write. It says the new rectangular garden will have an area that is 25% more than the original square garden. All right, that is the basis for our equation. So let's break that apart. The area of the new garden will have an area that is 25% more than the original. So 25% more than the area of the original. So I'm using AN for area of the new, AO for area of the original. All right. Okay, so let's build this equation up from left to right. Area of the new. We know that the area of a rectangle is length times width. So if I'm looking at my new rectangle drawing here, I can tell that I have a length of 2x and a width of x minus 3, which, if I were to simplify, would give me 2x squared minus 6x. So that's the area of the new. That's going to come over here. 2x squared minus 6x. Okay, equals. So that's the area of the new garden is, so equal sign, 25% more than the area of the original. Okay, so I definitely need to have an expression for the area of the original. So again, area is length times width. Here it's x times x, which is just x squared. All right, how do I represent mathematically 25% more? Well, if I were to find 25% of something, I would do 0.25, I'd move my decimal over 2 places, 0.25 of that original thing, which in this case is x squared. Now, this is only going to give me how much it's growing by. I have to add that to what was originally there. Okay, so 0.25 times x squared. So that's 25% of the area of the original, and I'm going to add that on to the area of the original. This represents, it's kind of like if you go into the store and you have to pay tax on something, right? You would take, say it's 8% tax, you would take 0.08, you'd multiply it times the cost of the shirt, and then you would add that tax onto the original cost of the shirt. That's how we do a 25% gain in area here. All right, so that is our equation that we just wrote. Okay, this is all you had to do for that first part of this question, is be able to write that equation all in terms of one variable. Now, part B is to explain it. All right, so I know everyone hates to do this part, but we got to break it down. So what I do when I explain these is I just kind of explain where each part is coming from. So 2x squared minus 6x. What did that represent? That is the area of the new garden. Okay, then the 0.25x squared is 25% of the area of the original garden. Oops. We add that to x squared to show an increase of 25%. All right, so something along those lines is what you're going to do to write down. You kind of want to break it apart. So why do you have the 2x squared minus 6x? Why do I have the 0.25 times x squared? Why did I add on an x squared? So you're just explaining how it models that situation. Okay, so now that I have that, I'm ready to move on to the bottom part. And the bottom says, determine the area in square meters of the new rectangular garden. Okay, so I rewrote my equation that I created in the first part of the question. And now if I want to find the area of the new rectangular garden, I first have to find out what x is. So I have to solve this equation. All right, so on the right-hand side, I have like terms that I can combine. I notice here that I have 0.25 x squared, and I have an x squared, which of course is a 1x squared. When I add those on the right-hand side, I'm going to get 1.25 x squared. Okay, now if I look at this equation, it's definitely a quadratic equation. Quadratic equations I always want to set equal to 0. So I need to subtract the 1.25 x squared to both sides and line it up with its like term. That's going to leave me with 0.75 x squared minus 6x equals 0. Okay, now if I look, I want to try and factor to solve this. So what kind of factoring can I do with 0.75 x squared minus 6x? Well, hopefully you recognize that there's a common factor of x, and I can factor that out. And I'm left with 0.75x minus 6. At which point now I can t-chart, and I get x equals 0, and I have 0.75x minus 6 equals 0. Okay, so solving the right-hand side, I would add 6 over. So 0.75x equals 6. Divide by 0.75 to solve for x. And I get x equals 8. All right, so I now know x, and a lot of students would want to stop here. But did we answer the question that was asked? They asked us to determine the area of the new garden. Well, if I go back up to the top and look at what was the area of my new garden, okay, if I go back up here, I can see that the area of the new garden was written right here as 2x squared minus 6x. So I'm going to come back and I'm going to take my, my x, and I'm going to replace it. So 2x squared minus 6x, I'm going to plug in my 8 in for x. So 2 times 8 squared minus 6 times 8. I type that into the calculator and I get 80. So 80 is the area of the new rectangular garden. Okay, we're moving on to page 72, and we're looking at number 14. These questions are fairly common, where they ask you to compare maximums or minimums of quadratic functions. So in these 4 choices, hopefully you recognize that you have a table of values, a graph, and then 2 equations. I always want to look at my table of values and my graphs first, because those I can clearly recognize the maximum right from them. Okay, so taking a look at f of x is a table of values. If I'm looking for the maximum, that means I'm looking for the turning point or the vertex. Okay, I know that in a table of values I'm looking for the repeats. So here I can see I have -3, 5, 5, 9, 9. That means my vertex is going to be smack in between these points, 1, 9, and 2, 9. All right, so I don't need to find exactly what it is. What I know is it's just going to be slightly higher than 9. All right, looking at g of x, I can just visually see the vertex is right here, which is at 1, 2, 3, 4 in a little bit. So it's between 4 and 5. Clearly, right now, f of x has a larger maximum than g of x, so I can eliminate that choice. As far as h of x and k of x, choice 1 and 2, I would strongly recommend just graphing them in your calculator and looking at the picture. So I'd like you to go ahead and do that now, graph both of them, and I'm going to do it as well. Okay, so I took a picture of the 2 screens that I had for h of x and k of x, and you can clearly see that for h of x, okay, the maximum is right about here, which is a little bit more than halfway up your screen, so it looks like about 6. Here, the maximum is up here. It's off of the screen, which means it's higher than 10, because we know that on our traditional graph, when we graph on our graphing calculator, it's from -10 to 10. So that means our maximum for k of x must be bigger than 10, which then is bigger than all of the other options. Okay, the last one we're going to look at today is on page 89. It is again a number 37, which is a 6-point question. So 2 exams in a row, we had quadratic based function questions for the 6-point questions. One was obviously the word problem. That was the last one we did. And this one is looking more at a graph of a quadratic function. So let's take a look at this. A football player attempts to kick a football over a goalpost. The path of the football can be modeled by the function h of x equals negative 1 over 225x squared plus 2/3 x, where x is the horizontal distance from the kick and h of x is the height of the football above the ground. Both are measured in feet. On the set of axes below, graph the function y equals h of x over the interval 0 to 150. This is super important. Many students, when they actually tried to answer this question on the exam, ignored the interval. This is telling you on your x-axis, this is telling you what you should start at and what you should end at. That's telling you that when you're graphing down here on your x-axis, you need to graph from 0 to 150. Okay? So let's think about what would we want to count by then in order to cover a distance of 0 to 150. So you can try different options, but actually it works out very nicely that if you count every other line as 10, which is like saying every line is 5, it works out perfectly. So I'm going to go ahead and pause and finish labeling my x-axis. You go ahead and finish labeling yours. Okay, so you can see I started off labeling every other one as 10, and then I ended up just kind of putting the tick marks down and then just labeling the 100 and the 150, which is perfectly fine. Okay, I've set a scale and I maintained it from beginning to end. All right, now I'm ready to graph it. Well, clearly I want to type this into y equals. One thing I want to give you a heads up on is even though we use the alpha y equals a lot to enter fractions, I don't want you to enter this in your calculator using the alpha y equals. Please enter it using -1 and then just use the divided by 225x squared plus 2 divided by 3x. Okay, the reason why is if you enter it using alpha y equals, you're going to get answers back in your h of x that are fractions. And we don't want that. We want nice, pretty whole numbers. Okay, so let's go ahead and enter that into y equals, and we are going to get a table of values. Okay, so after I enter it into y equals and I go to my table of values, which hopefully you're doing along with me here, when I enter it in and then go to my table of values, what are my x values going to be counting by in my table? Okay, so I added a little screenshot here of my table of values that I was getting, and you can see here that it's counting, my x values are counting by 1. Is that what I want? No, I have to get all the way from 0 to 150. My x-axis is counting by 5s or 10s. I certainly do not want a table of value that's counting by 1s. Okay, so let's remember that we can change how we count our x values by. So if we go to second window, or second table set, we can start our values at 0, which is where we're starting over here on the x-axis, and we're going to count by 10s. So everybody go ahead and change your table set to do that. Okay, so now we have a table of values that looks like this. And now you can see your x values are counting by 10s, and so we're going to be able to use this to grab a few of the values between 0 and 150. One thing you should be thoughtful of is exactly the shape that this graph is likely to take on. Hopefully you noticed when we looked at this originally that this is an x squared function. So in fact, we're looking at a quadratic, which is going to be a U shape. And because it's a negative number in front of the x squared, it's going to be a downward facing parabola. Okay, which makes sense if we're thinking about a height of a ball. Okay, it's going to come up and then back down. All right. Okay, so what I did was I copied down some values from my table of values that helped me get a good picture of what it is that I'm looking at. So you'll notice that I chose values kind of spread throughout 0 to 150. You'll also notice that I have values that are repeating a lot, okay? So I know I'm going to get that U-shaped arc, okay? So 0, 0, I have the 16, 16, 24, 24, and then I have this point right here, all right? I actually had to change my table set again to make it count by 5s in order to get that value. I recognized that I had this repeat, and so I knew that there must be a value directly in between those. Okay, so now I have my y values. I know how high my y-axis needs to go. Okay, remember the y-axis represents the height of the football. So here, I can tell that I need to go up to 25. So I'm going to go ahead and count by twos. 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. Okay, so that's plenty of room in order to have all of the values covered. So then I'm going to go ahead and plot those points on my graph. And you should be doing it along with me on yours. So 75 is obviously halfway between 70 and 80. Oops. And 25 would be just above 24, in between 24 and 26. Okay. 90, 24, 120, 16, and lastly 150, 0. So you can very nicely see the arc, the parabola that we can connect as our graph. Okay, so that was the first part, making the graph. The second part says determine the vertex of y equals h of x and interpret the meaning of this vertex in the context of the problem. All right, well, we've kind of already talked about the vertex, or the turning point, is the value that's in the middle, okay, of your table, the one that doesn't have a repeat friend. And so it's also the highest point, so it's the 75, 25. So 75, 25 is the vertex. In order to interpret the meaning, I have to clearly know what my x and my y stand for in this problem. If I go back to the beginning, I underlined what x and y stand for. Here I said x is the horizontal distance from the kick, and h of x is the height of the football above the ground. So I'd want to say something along those lines. I'm going to explain the meaning of it using those words. So I'm going to say that when the horizontal distance from the kick is 75 feet, the height is 25 feet. Okay, so super important to take the information directly from the question. They exactly told you what x and y were, or x and h of x were. Use that information when answering the question. Don't make it up yourself. Okay, lastly, the goalpost is 10 feet high and 75 yards away from the kick. Will the ball be high enough to pass over the goalpost? All right, so the goalpost is 10 feet high and 45 yards away from the kick. Many students got caught up on this. This whole problem, what unit of measure were we using? Hopefully you recognize that we've been using feet this whole time. And then all of a sudden they throw yards at you. So here, 45 yards, okay, away from the kick, well, that sounds like your x value. So here they need you to understand that we're 45 yards, but how many feet is that? Because my x-axis is measured in feet. So I have to convert this to feet. So I have to ask myself how many feet are in a yard, and I know that there are 3 feet in 1 yard. So I'm going to write the fraction that way so that my yards will cancel. 45 times 3 is 135 feet. So now I'm reading the question like this. The goalpost is 10 feet high and 135 feet away from the kick. All right, so 135 feet on this graph is where? Well, 110, 20, 35, looks like right about here. Okay, so just from the graph alone, I can tell that that is under 10 feet. So will the ball be high enough? I would say no. So I'm going to say, no, it's not going to be high enough. Because when x is 135 feet, h of x is less than 10. Thank you so much, ladies and gentlemen, for sticking with me. I know we had a couple long questions tonight, but I'm hoping that you are finding this review beneficial, and it's going to help get you ready for your exam and just remind you of things that you need to know that are super important to do the best job you can do on that final exam. All right, we'll see you in class next time.